Welcome to Study Loop.
So here we're given some pairs of solids, and we're asked to determine which species between the two things in consideration is going to have a higher melting point. So first we're taking a look at titanium oxide versus hydrogen peroxide. And the important thing that we should first take a look at here is the fact that titanium oxide is an ionic species, while hydrogen peroxide is a molecular species. And because hydrogen peroxide is a molecular species, it's going to be held together by dispersion forces, but its major force specific to it is actually going to be hydrogen bonds, whereas titanium oxide is going to be held together by these ionic bonds. And those are going to be generated by the fact that titanium has a positive charge, and the oxygen here is going to have some degree of negative charge. So because we're talking about the interaction between two straight charges as opposed to dipole moments that we're going to be getting with the hydrogen bonding and hydrogen peroxide, titanium oxide is going to have the higher molecular forces holding it together, which means it's going to require more energy to break up those forces, giving titanium oxide the higher melting point. Now, if we move on to part B, we're comparing carbon tetrachloride to silicon tetrachloride. And carbon and silicon are both in the same group of the periodic table, which means that at the standpoint of the interactions between each of these respective molecules in their solid, they're going to be pretty much identical. The only difference here is if we look at the molecular weights of carbon compared to silicon, silicon is heavier than carbon. In the same way it takes more energy to get a larger plane to take off than a smaller plane, it requires more energy to lift heavier atoms and molecules. Because of that, silicon is going to have a higher melting point because it just is heavier. We move on to part C. We're going to consider krypton versus xenon. And we're going to have the same thing going on here. So these two species are both within the rare gas, the noble gas block of the periodic table. So their solids are going to be holding them together by the same degree. The only difference here, again, is going to be weight. So because xenon is heavier than krypton, it's going to have a higher melting point than krypton. And finally, if we consider the comparison between sodium chloride and calcium oxide, we're dealing with two ionic solids here. So both sodium chloride and calcium oxide are going to be ionic. So the main thing that we're going to be considering here is the difference between them is the magnitude of their charges. So sodium is a single plus, chloride is a single negative. However, calcium is a 2 plus cation, and oxide is a 2 minus cation. So because the degree of charge is higher in calcium oxide, it's going to be holding these two species together even harder than the single positive charges in sodium chloride. If you want to think of an analogy for this, this is somewhat similar to the way a large magnet is much more difficult to pull apart when it's stuck to another large magnet versus two smaller magnets being held together. So because the magnitude of charge on calcium oxide is much higher than sodium chloride, it's going to have a higher melting point.